So this presentation is about writing a research report. So research reports are something you have to do on a regular basis. The PhD students will have to do it every 6 months. The master student at the end of their stay. The postdocs also every 6 months. And I thought it would be good to have a video concerning this topic so we all have the same guidelines and structure. So at first, the outline of this talk is why reports matter. A short view in terms of bibliography, the structure of a report, regular jobs that need to be done to be able to write a report, how to start writing a report, what to include, how to write, etc., and conclusions. So why do reports matter actually? So all your 6-month reports combined will make a thesis. So if you do that on a regular basis, at the end of your PhD, you will have 5 reports, and then you can write your thesis, and it should be actually a piece of cake because it's more or less combining your 6 research reports. It will help you also from time to time to step back and take a look at what you're doing from the outside perspective. It will help you to summarize and get a more global idea of your research work, and you will be able to have time to do some extra literature research. So typically I ask the PhD students and postdocs also to stop their work at least for 2 to 3 weeks to do a solid work on their research report. So that it would be entirely dedicated to writing this time. It will also help you to see where your experimental data is incomplete. Maybe you're missing some high resolution mass or some other important data. Your master report will also be very important when applying for a PhD position. So in terms of recruitment, I personally look very carefully into these reports, and you can see immediately if somebody invested time and was rigorous in terms of documentation. The same is true for postdoc positions. Typically you do a presentation of your PhD thesis, but it might also be that your postdoc advisor might ask you for your PhD thesis to see what is your level of writing skills. Every report helps you to become a better writer. Obviously, as for everything in life, practicing, a lot of practice makes helps you to make a better job. And it is the only witness of the work you've done. So apart from your report, basically nobody will look into your laboratory journal anymore. And if somebody wants to know what you've done, they will check your report or publication later on. In terms of bibliography, even though it's not completely related to reports, but it's related to papers, which is a very small report, there is the paper by George Whitesides. So this is the chemist who was the most cited at all times so far. And he wrote a paper which is mainly about how to write a paper in his group. So it addresses itself to his group members, that people will have an idea how to write a paper. There's also a book, which is The Chemist English. Obviously, English is not our mother tongue, or most of us will not be our mother tongue. So you can do some extra literature research in terms of how to better express yourself in English. So how to do a report? First thing is also in terms of literature that I put these documents on the drive. So here you have the paper by George Whitesides, a video to his about his philosophy about writing a paper, and you also have a document or presentation in French about writing a report. So this is nothing I did, it's from somebody else. But these are good resources in terms of how to write a report. As I said, here this presentation in French. We also have other documents on the drive. Here, for example, how to do a graphical abstract, how to prepare your data, and also how to do common abbreviations. And I really want you to follow these instructions here, because it takes a lot of time when I have to correct every time. Maybe you write minute, MIN with a dot, or equation, equiv with a dot, and I have to delete the dot and so on, or I have to add spaces. So please carefully, especially look at these two documents which are on the drive. I also placed a report example. So that's another report here. I think its new name is example. Also NMR spectra, the way I want them to be presented, with a structure on the top left. And obviously you go from minus 0.5 to 10 typically. So this is described in this document here, data preparation. You can also be a little bit more generous on the left and on the right. And here the cover. So we should all have the same cover here with these symbols on them. So in terms of structure, for a master or PhD thesis, acknowledgements and list of abbreviations is included at the very beginning. This is not necessary for a 6-month or a postdoc report. So we typically start with a list of contents, then there will be an introduction, the objectives, results and discussions, conclusions and perspectives, experimental part, and references and appendix. So let's go to the first part, introduction. So let's say your thesis is about a reaction, which is the conjugated addition with kappa reagents. And so you have to define first what is the most important about this transformation. Because once you identified what you want to talk about, because you can talk about a lot of things, then you can actually be more specific. So what is interesting? Is it the product? Is it the reaction? Is it maybe even the starting material? Is it the reduce selectivity? Is it the diastereoselectivity? selectivity? Is it the enantiomer selectivity? Is it maybe the role of kappa as a green metal or sustainable metal, and so on? So this is the first question you have to ask yourself. What do you want to aim on? What is the most important thing? And obviously at the beginning you might be confused, you don't know really, so ask me and I can help you to identify what you should be writing about. Second, once you've identified what's most important, please give relevant details. So a short historical overview, so who has done what, obviously site reviews if there are any, and the most important papers. And then go from a general introduction, get more and more specific, right down to the topic. For example, write about conjugate additions. Then you can write about asymmetric conjugate additions. And finally, you go to the topic of your thesis, which might be asymmetric conjugate additions to heterocyclic systems. So that's very common in organic chemistry, that this topic here has been done in the 60s, 70s, 50s, so a long time ago, maybe sometimes more than 100 years ago. So you're probably on a very specific topic. So you have to go from general to more specific to give the reader an idea in which specific branch you're working. So go from general to specific, cite the most important reviews and papers. You might need also help for that, especially in the beginning of your thesis. You might obviously not have the general overview of what are the main papers or where you can find them. So don't waste too much time in doing the bibliography. I've probably done it, so I will give you some papers and I can direct you to certain reviews. In terms of structure and objectives. So objectives, so this is included in the topic structure. So in the objectives you have to address what are the central motivations. So why is there any need to do research? And obviously you have to highlight maybe issues with the literature. So maybe they can do all kinds of conjugate additions, but not to heterocyclic systems. So this is why you want to do it. You want to do something new, something that nobody did before. Or maybe you are focusing on a reaction which is already known and you want just to optimize it. They get 30% yield and you want to achieve 90% yield. So this is important to outline in the objectives. Also, if there are any hints in the literature that indicate that what you're doing is reasonable or if there are any discouraging reports. Maybe you found them later on that some things actually cannot work. And this should be also in the objective. So this is my global aim. That's what I want to do with a scheme. That would be nice. And also to discuss why you think it's working or why it is not working. In terms of structure, you will see that often in publications. So that's a very recent JAX paper where you have typically previous work, and they would do some general schemes and say who has done this previous work. So this is the introduction. So you're talking about the literature, you're identifying who did what, and then you identify basically what is still maybe an alternative method which is needed to do these kind of products, or an optimization, etc. So this is the introduction part, this is the objective part. Then let's move to results and discussions. So typically you focus on one example at the beginning of your thesis, which you optimize, at least when you're working on methodology. For example, here, this is a reaction I did during my postdoc, and I screened reaction conditions. So this is something you should include. Include a table, discuss it, and arrange things logically. Let's say if this would be here, if you would have one entry diethyl zinc, don't place it before triethyl aluminum. So diethyl zinc, triethyl aluminum, ethyl magnesium bromide, and then again ethyl zinc, ethyl zinc. Combine things which are together, which need to be in a logic. So don't list 10, 60, and then 5 minutes, but in a correct order, 5, 10, 60 minutes. So it should be done not in a chronologically way you did your experiments, but in a logic way. So this is the way things often are presented in the literature. Here it's a little bit different. They present the best conditions and then they say deviations. So this is more something you see in papers, but for reports I personally prefer bigger tables and really what you did. So as you can see here, often they refer here to the experimental details, to the SI. This could be sometimes maybe lacking some details. So give enough information, maybe add even a column or more, but don't show more than 9 entries. If it's more than 9 entries, I cannot follow any more the logic. Then you have to subdivide. So maybe combine all the diethyl zinc or the experiments for ethyl magnesium bromide and triethyl aluminum. So don't show me 2 big tables. That would be at some point too complicated to interpret. Something you also should do is obviously check carefully your tables. It's annoying when some data is missing or something which is not logic, maybe yields over 100%. So try to be as rigorous as possible. So the more rigorous you are, the less I will complain. Take time also to discuss your data. So for example, the higher the temperature, the better. If you see things that don't make sense, only include it if you have repeated the experiment several times. So sometimes in chemistry we have something which is called an issue with reproducibility. That means we do several times the corresponding reaction, and we get every time a different results. So this obviously cannot be interpreted in terms of logic. So if something is strange, then reproduce it. You can show it, but please only show it when you've reproduced it. So for example, here's something I've seen in the literature. What you can do also is to discuss things which are not very clear to you. So here, for example, they say prior work from our lab has shown that chloride anions can modulate the coordination sphere of copper complexes, resulting in a proposed shift in redox properties and reactivity. Okay, so they've seen some kind of shift, which they think that's probably from chloride. While the exact role of chloride in the present transformation remains under investigation, that means they don't really know what's going on. Preliminary data suggest that this X-type link is suppressing off-cycle reduction of something, okay, to fluoroform by low valent copper, okay. And so they don't really know what's happening, but they suggest the proposal of what is probably happening, and they say this proposal is supported by key observations. So that's something you should do. It's more or less, you can say, I don't really know what's going on, but I did this and this and this and this, and that's probably all pointing towards a certain mechanism that I think is working. So always base your argumentation on observation. As you can see here, don't just say it's not working or I believe this is like that if you have no proof. So at least give some, even if it's not completely proven, but at least give some hints from experimental data which points towards a certain direction. Take also compare your data. So the reaction conditions are milder compared to Smith protocol. Say what's good about your chemistry, what's bad about your chemistry. For example, unfortunately, our yields are lower than. So be very honest in terms of discussion. This is not a paper. This is not something where we have to hide problems, but you basically discuss the reality. Show what's working, show what's not working, where you have a problem of reproducibility, so we can check what's happening. Please only include data that means something. Don't include every experiment. For example, I dropped the flask, half of the compound was spilled, the yield was low. So I'm not interested in that, because obviously it's low because you spilled some of the compound. So this means you have to redo the reaction and check the real yields. If something did not work, please discuss it, but only if you have tried to make it work, or at least done some major efforts to check why it's not working. So for example, no reaction was obtained at room temperature. At 40 degrees, 10% conversion was achieved, giving the expected product alongside some non-identified products. Heating at 80 degrees afford a complex reaction mixture. So this tells me you've tried, but it's simply a dirty reaction and there's not much we can do about it. So don't just write it did not work. Always try to do it to be as specific as possible and express yourself in a scientific way. Then once you sort of discuss the specific example, go to more general, go to other examples what you've tried. So there's a recent JACS paper by Macmillan. So as you can see here, the general reaction is shown on the top. Ligands on the right hand side if needed. They did a division of primary and secondary alcohols, and they did discuss here, I don't even know what this is. This probably 80% maybe NMR yield, I have no idea. 55% maybe isolated yield. So they discuss the different examples. Typically you would have then a long footnote with all kinds of things which you have to change and so on, because chemistry is rarely general. For a report, I think it's better actually to add modifications right under the molecule. So remember, this is not a publication, it's a report. And try to arrange your data that it would be as simple as possible to see what you actually changed for a specific example. So as I said, hardly ever method is general. There are always substrates which fail, and it is important to know why. So for example, substrate 1 bearing an electron donating methoxy group gave low yields, where a substrate 2 bearing a trifluoromethane group gave the desired product in high yield. So you know it's an electronic factor which is important. Or for example, substrate 4 bearing a bulky toad butyl group gave low yields, likely due to steric repulsion, etc. Here's something how it is presented today in the literature. So the Macmillan paper, we optimized conditions in hand. We sought to evaluate the scope of the present transformation. So that's, you optimize on one example and then you test the scope. That's a typical thing. And then later on we read, in addition, activated benzyl alcohols, etc. were obtaining good yields. This was obtained in good yield, and this here also in good yield. And sometimes they express some things which don't work well in a positive way. For example, gratifyingly, a hindered neopentyl alcohol was trifluoromethylated to deliver 29 in a synthetically useful 44% yield. So it looks almost like it's a good thing, 44% yield. if you start with gratifyingly and you sort of insist on the challenge.